Oh, okay, hi Aditya. So I'm just going to start recording. We are in lecture number 23. We started a little bit late, started recording a little late. We were just talking about um, Jacob John's presentation on Thursday, which I realized that I only have 16 minutes recorded. So I think I must have forgotten to start recording when he came up, when he came back online. Mm. And anyway, my plan today is to talk, continue our discussion about numbers and thinking with data. Um, and as I said on Piazza, we won't have a tutorial on Wednesday. What I'd like to do is have a joint tutorial on Friday, and in fact, it just struck me that it might be nice to have it an in-person tutorial. So I can at least get to see some of you. Does that work? Friday, how many would be able to come
Yes,
in
sir.
person on Friday?
Yeah,
Yes,
I would.
sir.
In persons are better.
Okay. Do me a favor. Somebody send me an email to remind me to do this. Always post in Piazza. I won't remember right now, and then I'll make a room booking and then we'll do it then. That sounds like fun. Um, so let's continue then with um, the discussion. Today's readings, we're going to talk a little bit about this material from uh, Calling Bullshit on selection bias, and then from Kahneman in that chapter called The Law of Small Numbers. And I would say that we're doing two kinds of things in the material. One is the material in general is providing us some lessons and rules of thumb for how to go about reasoning, particularly in the context of data. So, rule of thumb might be in the case of calling bullshit. In this context, well, uh, think about the samples from which you're drawing your conclusions, and then and that's something that Kahneman also is very keen that we start doing. And the other thing that reading is providing, and you see more of this in Kahneman, is some insights into how the mind works that might explain why we tend to get things wrong in this particular domain. And it's important to think about, or to be aware about the domain question, because remember we started out in the domain of language, uh, and now we're in the domain of numbers. And it may be that our minds are just better at working in one domain rather than uh, the other. Excuse me. And certainly, Kahneman's kind of idea is that, well, Kahneman's conclusion is that our the system one module or the system one component of our mind is actually pretty bad at uh, doing certain kinds of um, statistical reasoning. Um, so let's start from, well, maybe before we get to the details. Um, One nice frame for this discussion is uh, that acronym that Kahneman talks about from the previous chapter we read. Remember this? What does this stand for, Vizyati? This is from that chapter on jumping to conclusions. Chapter 7 of Kahneman's text. Do people remember this?
I remember this word, but I don't know about why it was used. Basically, I just ignored. I think that there might be a typo.
Actually, okay. No, no, it's very far from being a typo. So let's do this. Let's go back and review this because it's an important concept for Kahneman. Let's go back. Here we are. So this is the point that he makes in the last chapter, which is the title, which is titled "A Machine for Jumping to Conclusions." Um, well, our minds, specifically the system one component of our mind, is very good at, or tends to, jump to conclusions on the basis of limited evidence, and the important point there is system one is not very attuned to thinking about the quality of the information. The system one is radically insensitive to both the quality and the quantity of information that gives rise to impressions and intuitions. In general, there are these two dimensions for thinking about um, evidence in actually any domain, right? Hi, for some reason it bumped me off. Can you guys hear me now?
Yes, sir. Now we can hear, but after sometime before sometime, we couldn't just.
Okay, so um, you could hear me. I mean, to see the when I was reading out this passage, right, where he um, introduces this term Viziati,
Yes, sir. Yes, sir.
which you see is all there is. I was saying that one way of thinking about the general point that Kahneman wants to make, well, he wants to make many points in the book, but in for our purposes, is you can think of any kind of evidence as having two dimensions to it. One dimension is, okay, what's the evidence for? Um, uh, what can you glean from it? What can you infer from it? And the other aspect of the evidence is how reliable is it? Can we actually even trust it? Um, and what one of the things that Kahneman wants to say is that that second question is not it's not a question that comes easily to system one. So we are um, programmed in a sense to not ask broader background questions when you're faced with some kind of evidence of, well, how good is it? I think that question about how good the evidence is not something we even looked at in our discussion of science, right? Presumably in actual scientific work and experiments, you do have to care, were the test tubes cleaned properly, were the protocols followed when you perform the experiment. But in a way, that's sort of taken for granted in the background, even of um, hardcore theoretical work. And Kahneman's point is, but don't take it for granted, or recognize that if you take it for granted, then you can be led into error. And so if I had to say, um, if I had to give kind of one take-home lesson that I take from the readings from today, it would be when you see some conclusion on the basis arrived at on the basis of numbers, be mindful of the source of the data that's being presented. And in the case of calling bullshit, which we'll turn to in a moment, that issue is selection bias. Have people come across that that phrase, selection bias, before? People also speak of selection effects. Is that familiar? Well, maybe one can introduce the notion from with the text of the reading itself. So they're talking about, and this may be alien to me because I've never skied in my life. I've seen skis on television and so forth. But it's a simple point. There are all these different ski resorts, and there's a ski resort called Solitude, which is for these like very committed skiers. Doesn't seem like such a big deal. And then one day, one of them, Carl Jevons, goes to ski at Solitude. That the people there are really excited about the snow, the family atmosphere, etc., etc. And now he thinks, hey, I have underestimated this place, and it's got so much good, so many good reviews from people who've been there. There must be some amazing skiing. 2/3 of the people like this place even more than these the other ski resorts. That's amazing praise. And what's the point, or what's the point of the? His father says, yeah, there's a reason why the people you're speaking to are so into the ski resort. They wouldn't be if they weren't there. If they weren't so into it, they wouldn't be there. So there's a you're impressed by something that's really an artifact of where you're looking, and they have a nice slogan, which is what you see depends on where you look, or where you look determines what you see. You can see in that slogan also, right, that there are two different dimensions. There's the dimension of what you're seeing, and then there's another dimension of look. Is what you're seeing representative of the population as a whole, or is that making a difference to what you're seeing? Aditya, go ahead.
So a similar case happened, I think, in World War II, in which they sent planes, and when the planes came back, they thought that they should increase the armor on the planes. All right. So they had statistics on where the planes which came back to them had all the bullet holes on them, and they said that the places where there are the most bullet holes, we should put the most armor because those places get hit more. But then there was the statistician in the employ somewhere who said that no, armor the places which are the least bullet holes because those places are not coming back.
Right.
The planes that get hit at those places don't come back. And
that's what must be the most vulnerable.
That is the most vulnerable part. So it was an example of like it was a subset of the survivorship bias, a subset of selection bias. But yeah,
that's a great example. Where did you come across it?
Like multiple places. I think it's a pretty common example.
I've also heard the example, but I'm wondering what the source is. Maybe it's in Thinking Fast and Slow itself. I can't recall. That's a nice example. In a way, when you have that filter on the world, it's a pretty powerful filter to think about the ways in which your experience of the world is being filtered through all sorts of, essentially funnels that you may not be aware of. I remember I had this friend when I was studying in the US, and certainly, this is 25 years ago, right? So often um, Americans who meet you like, wow, I didn't know Indians could speak such good English. That is a thing that one heard. And he says something like, yeah, everyone in India speaks English. You think, oh, wow, he's has a very, and it's from the south, so that's more of an English speaking from Karnataka, certainly more of an English speaking state than the north, but still, probably a very, very small minority of people there speak English, and maybe he mostly just hung out with that crowd. In a way, you can think of if you recall one of the Chomsky clips, where he says it's not as though that interviewer is being asked to bias things in favor of certain ideologies, but look, the fact is that if he hadn't had those ideologies, or he was soft on alternative ideologies, he wouldn't be there to begin with. Anyway, the Colin Butchett has a bunch of these sorts of examples, and most of them I think are pretty straightforward. Think about whenever you ask a question which you're trying to get a sense of, how some population behaves with respect to some kind of variable. Think quite carefully about how or in what ways your filters towards that population are, bias is maybe too strong a word because it doesn't have to come out of some bias which one thinks of in a negative kind of way, but it's, all of our information about the world is filtered, and then the issue is to have some awareness of the ways in which these filters work. Can you think of other examples of selection bias? Actual examples or possible examples? What would happen if you did a study, if you wanted to find out how many people are going to, if you want to do a pre-poll survey of elections in some state, and you decided that you're going to do the poll by phone, and you get these lists of mobile phone numbers, and you call people on their mobiles and ask them who they're going to vote for. What kinds of selection effects do you think you might see? Did you guys understand the question? I'll type it out.
I think can you type or repeat?
Um, So you can buy these databases of people's phone numbers, and that's how you get spammed. So my question is, you know what a polling organization is, right? A polling organization.
You will only get to know about people who have phones and not about people who don't have phones.
What percentage do you think that is? Let's say in a state like UP.
I don't really know.
Order of magnitude? Do you think it's like 1% of people,
So,
or
like somewhere between 50 to 90. Like
50 to 90?
let's go, but like let's say 40 to 90. Like somewhere around the like more than 30%.
More than 30%?
Not above 90%. Like I really don't know this. Like at best I can ballpark the magnitude. Like I said, right? I don't know.
So I am just well, it'll take a while to
I tried to look at statistics too, but I couldn't find any.
Yeah, I mean, it's also tough, right? How do you actually do this? One of these things to figure out how good is the methodology of studies that try and show this. But look, if it was 30% of Indians have smartphones or 30% have mobile phones, that's a huge number of people who don't, right?
I don't think it would be as low as 30%, but it could. Like I don't think it would be, but it could be.
Any other guesses?
Sir, on which we are making guesses like.
I'm asking. The question was what percentage of, well, the broader question is, let me just put it out here. What selection effects in their study? That's the question, is what selection effects would you expect to see in their study? And Aditya rightly pointed out, well, you're only going to you're only going to find people who have access to mobile phones. And so then we have to ask the question, well, what fraction of the population has access to mobile phones? And that is my question to you. Do you have an estimate of?
Mobile phones. I think, sir, in India, maybe around 60 to 70% people have mobile phones.
60 to 70?
Maybe
I was saying 50 to 90. That was his.
Maybe more than 70. Because in India,
35% of the population has smartphones.
Yeah, we are not talking.
Yeah, we're talking
about smartphones.
It's a floor, right? It has to be more than that.
More than 35%. So what do you think? What do you do? I mean, this is pretty obvious stuff, right? So what might the characteristics be of the population who don't have smartphones? I mean, not who don't have mobile phones.
They probably would be more poor, less urban.
They might be more poor because you think this is a pretty basic necessity now for lots of kinds of jobs.
And there will be less urban because urban people tend to have more phones, I think.
Maybe. What else? Anything else?
Like most I can think of are the knock-on effects of being poor, right? Like nothing direct.
Might be the knock-on effects. Well, I've seen then there might be effects in terms of this person has to pick up the phone when you call them, and there may be selection effects for the kinds of jobs you might have that allow you to pick up the phone in the course of a day.
I mean, yeah, and also you also select for the type of people who pick up the phone when random numbers call, because most people don't.
Most people don't. So why is all of this interesting? Because again, you might read in a paper or watch on TV. This is after all, something. If at all you're interested in elections, you're faced with this kind of information all the time that look, this is what we predict. This this party will win this election, and it's just worth being very conscious of this question of, you know, well, how on are people saying this, and what is the population that's actually being asked this question. There's some wonderful articles by this economist whose name I've mentioned to you before, Jean Rez, who writes about this a little bit. So anyway, so that's the point about selection effects or selection bias. Other examples people have where this might be useful to think about? By the way, this tends to be, I would say, a particular problem for, you know, if you're a decision maker of any sort who belongs to any kind of elite. You know, if you don't go beyond, if you don't make an active effort to kind of go beyond your bubble, you're going to be making decisions based on a very skewed proportion of the people whom your policies are affecting. Like if I decided to that the world was, if I decided that, you know, IIT students are a representative sample of the country as a whole, and I just you know, made my policies as a, you know, as a minister in the government based on the conditions of IIT students and their beliefs, which I might do, right? I might do, for instance, if I was a graduate of an IIT, then my kind of worldview might not go beyond that of the fellow students that I have, or the family that I came from, my friends. I might end up having a very a very skewed idea of the way the world actually is. So I think as decision makers, it's very important to be conscious of this form of effect, and to go out of one's way to correct for it. Let's carry on then to the material from Kahneman. Go to the example of what he calls the law of small numbers. This is chapter 14, I think. Chapter 10, sorry, this is chapter 10 of Thinking Fast and Slow. What's the, anyone want to describe for me what that the example is, the kidney cancer example? In fact, why don't you take a moment to read it? I'm going to go and get myself some water. I'm going to switch off my camera, and why don't you read and think about the example and then we talk about it. Okay, so what's the point of the example?
It's about things that simply happen because of chance. Like if you have many things which can go in only a few ways, you will have groupings in which you would think that there are which show an underlying pattern or some causal relationship, but which are just artifacts of the statistics.
And what is in the kidney cancer example, what is the underlying explanation? So what's the phenomenon by the way? What's the phenomenon is interested in?
If a community is small, it has a higher variation, because if any person has an equal probability of getting cancer, some small countries, some small communities will have almost all people with cancer or almost none people with cancer, and this will be more easily true in small communities than in large communities, in which it will tend to average out. So
small samples have higher variance, and therefore you're more likely to see extremes in small samples. That's the underlying statistical point, right?
Yes, sir.
He makes this point on this page. By the way, I have a question. How would you calculate this? What's the how do you calculate these numbers? This is something that was doing like discrete maths and things, no?
So what are they drawing from?
They're just drawing from a large urn which has equal red and white marbles, and then they draw and then they throw it back.
So like we could easily say that the probability of getting all red if you're drawing n balls is 1/2 power n. Like this is pretty basic probability. So, and you get.
Yeah. I mean discrete maths and probability.
I'm not sure if more often than Jill by a factor of 8 is a correct thing to do here. Like I'm not sure if you can just divide them by that.
So it's 4 and 7. That's the two.
Yes, sir. So the probabilities 12.5 and 1.56 are correct. But I'm not sure if the factor of 8 is something which, like, sort of, like it's simply division. But I'm not sure if it's a fair thing to calculate, like, or if it is something that just happens.
I mean, this number is 8 times this number, right?
Yeah.
I think that ratio you think is not a meaningful ratio.
I'm not sure if it's a meaningful ratio here, but the percentages are simple.
Okay. So it's a nice example, right? And one of the things that he points out is that our minds are so nicely attuned to find explanations, and again, by our minds in this case, the system one is so attuned to to jump to conclusions. He has these nice examples of these authors. It's easy to infer that high cancer rates. Well, yeah. So what you have is these small population counties are rural and tend to be more right-leaning in political orientation. So if you hear about the fact that they also have low incidence of cancer, they think, okay, this is why we're so attuned towards looking for explanations, and in particular to causal explanations. You think it's because clean living, no air pollution, no water pollution, etc. And then suddenly you hear that it's the incidence of kidney cancer is the highest in the same, well, not in the same counties, but in counties that have the same profile, now you can infer that high cancer rates of these might be due to poverty, lack of access to good medical care, etc. And then the issue is the rural lifestyle cannot explain very high and very low incidence of cancer. And he has at the end of the book, at the end of the chapter, this example from the Gates Foundation. Do you remember that? It's about school sizes, about you know, the Gates. You know what the Gates Foundation is?
Basically, sir, I have heard this name, but no, maybe they are working in healthcare or education sector.
Who is the Gates and Gates Foundation?
This is Bill Gates. Like,
Bill Gates and Melinda Gates.
Yeah, so
they
it's a
do a
big
lot of charity, right? And that's through the Gates Foundation.
Yeah, it's a charitable foundation that has a lot of focus on essentially education and healthcare. So they, I think, are really focused on things like the eradication of malaria is one of their goals. It's a controversial kind of charity, but it's a place that Bill Gates is a very intelligent person, and I'm sure it's run by very intelligent people. But nevertheless, as Kahneman points out, they make the same kind of mistake. Right? Well, I won't scroll down there. They make the same kind of mistake. They look at the study that says a bunch of the schools with the the best scores turn out to be very small. So they think, aha, what we have to do is now we have to spend a lot of money getting small schools. And again, it's easy to tell a story. Small schools get better results because there's a better teacher-student ratio, and there's one-on-one personalized attention, etc., etc. And that's why these students are doing so well. And that's one of the nice lessons of Kahneman's work, I think, overall. And part of what made it, not just the work that we've read, but in general, so provocative is he often points out the studies they did would often be with like university professors or people with some kind of advanced degrees, people who one would think of as good thinkers, and they frequently found that even people with advanced kinds of training would forget about their training in the application of particular answers. For instance, as he mentions in this book as well, when you look at sample sizes, he says that they test whether researchers selected for mathematical expertise make similar mistakes, and it asks researchers to choose sample sizes, provide advice to graduate students, and what they found is that many of the people, well, there's a this sentence is not completed, but the point is that many of the people involved, including people with a really low expertise in that particular issue, are not are getting it wrong. And they're getting it wrong because they're trusting their instincts over what is mathematically appropriate. I'm going to read the rest of that sentence. Amos collected the responses of a group of sophisticated participants, including authors of two statistical textbooks, at a meeting of the Society of Mathematical Psychology. The results were straightforward. I was not the only fool. Every one of the mistakes I had made was shared by a large majority of our respondents. It was evident that even the experts paid insufficient attention to sample size. So one of the lessons very old study, so I don't know if it's gone out by further work, but it's that's pretty astonishing. Well, there are two things that are astonishing. One is that the fact that the experts don't pay enough attention to sample size, and the second that in fact the expertise in question is precisely to develop these tools that then you should use instead of your own instincts. Right, as they say, we also included a strongly worded recommendation that researchers regard their statistical intuitions with proper suspicion and replace impression formation by computation whenever possible. There's another nice example of this. In fact, if I recall, actually true of Kahneman's own department in Princeton. So there's again, I don't know how well established this point is, but I've heard it said a lot that the claim is made, I think, including by people like Kahneman, that interviews are a very bad proxy for ability, fitness for a job, because it's only one data point and it's affected by so many different kinds of things. You may have had a bad day, you may be nervous, you may not have a great facility with the language in which you're being interviewed. So in general, they think that interviews are a kind of bad metric on the basis of which to make hiring decisions. And yet I think the Princeton psychology department would continue to use interviews as a screening device in their admissions processes, at least in their faculty selection processes. So one of the kind of standard, I would say standard, one of the repeated lessons from Kahneman's work is experts often get things wrong, and that in a way is a kind of curiously democratic sort of sentiment. So that's one point to make with respect to the issue of the sample. The broader point, as I said, look, this is a point about how our minds work, and he puts it quite nicely. Why don't we have somebody just read this passage, starting with a bias of confidence over doubt. And Hemant, since you're going to raise your hand first, look, I decided to call upon you. So we do Hemant and then Sumedha.
A bias of confidence or doubt. From there?
Yeah.
In a telephone poll of 300 seniors, 60% support the president. If you had to summarize the message of the sentence in exactly 3 words, what would they be? Almost certainly you would choose elderly support president. These words provide the gist of the story. The omitted details of the poll that it was done on the phone with a sample of 300 are of no interest in themselves. They provide background information that attracts little attention. Your summary would be the same if the sample size had been different. Of course, a completely absurd number would draw your attention. A telephone poll of 6 or 60 million elderly voters. Unless you are a professional, however, you may not react very differently to a sample of 150 and to a sample of 3,000. That is the meaning of this statement, that people are not adequately sensitive to sample size. The message about the poll contains information of two kinds.
Hang on. Just like, is this stuff that you guys learn in the course of your undergrad studies? Like, what's the appropriate sample size upon which to draw upon some kind of conclusion with I don't know, at some level given of confidence, at some given level of confidence? I guess what I'm asking is, and I don't know this. I feel like I want to spend part of my summer thinking about, or reading up more on probability and statistics. But my question is, in your training, would you have the tools to react to the difference between 150 and a sample of 3000? So tend to think of this as broadly the same.
Contrary to this thing, I have recently had my biology lab, so that's an instance from there. We had to verify a law, which like of direct proportionality or something like that. And what we did was we took up like 5 or 6 sample points, and uh, we tried to adjust like the errors and everything inside the margin, and we had to conclude that yes, it follows the direct proportionality. But
Okay.
like the sample size was so small, like just 5 and 6 points, and you are generalizing a law. I mean, from experimental point of view, uh, that's reasonable given the time limits and everything. But we don't really like consider that we need to test on very large sample to actually draw a conclusion and things like that. I mean, not in our studies, maybe in research people do, but up to my experience, we haven't been told to do things like that.
Okay. Anyone else?
There's also, I think, like in some cases you only need a small sample space, and in some cases you need a big sample space. Like stuff like sociology and psychology really need a bigger sample space than, for example, physics or chemistry or biology, because physics or chemistry or biology are simpler and more cleaner than them. They have less factors which affect any given answer.
Yeah, I guess the size of the sample, this depends partly upon how, I mean, the nature of the underlying, how diverse the population you're considering
Like
is. Right?
if the population, if the thing you're sampling from has a lot of noise, you will need a bigger sample space.
That's right.
But if the noise is either easily controlled or very less, then you don't need a big sample. So you can manage in small size also.
That's right. Right. I mean, at the limit, if you had a completely homogeneous sample, I mean, population, you just need one data point.
Yes, sir.
Okay. So Hemant, why don't you carry on the passage, and I'm just going to check with the textbook.
I think the message about the poll contains information of two kinds: the story and the source of the story. Naturally, you focus on the story rather than on the reliability of the results. When the reliability is obviously low, however, the message will be discredited. If you are told that a partisan group has conducted a flawed and biased poll to show that the elderly support the president, you will of course reject the findings of the poll, and they will not become part of what you believe. Instead, the partisan poll and its false results will become a new story about political lies. You can choose to disbelieve a message in such clear-cut cases, but do you discriminate sufficiently between I read in the New York Times and I heard at the water cooler? Can your system first distinguish degrees of disbelief? The principle of WYCIT suggests that it cannot. As I described earlier, system first is not prone to doubt. It suppresses ambiguity and spontaneously constructs stories that are as coherent as possible unless the message is immediately negated. The associations that it evokes will spread as if the message were true. System 2 is capable of doubt, but it can maintain incompatible possibilities at the same time. However, sustaining doubt is harder work than sliding into certainty. The law of small numbers is a manifestation of a general bias that favors certainty over doubt, which will turn up in many guises in following chapters.
Okay, so just pause there. So this is a kind of deep and an interesting point, and I wish actually he'd spend more time unpacking this. There are two things to focus on. So one is just this point about the story versus the source of the story. We already talked about that story. Is the source of the story. We tend to just focus on the story unless facts about the source of the story become very salient. Like if you come to know that the story has come from a polling agency which is under contract from the president, or something like that. But the real point he's making is about the fact that our system one is not, we're not built to kind of grade levels of confidence in the reliability of some form of evidence. So it's easy for us to do like a 0-1. Either you believe the story, let's say you believe the that the LLE do support the president, or you believe the opposite. You reject the findings of the poll; they're not part of what you believe, and now you're onto some new story. So when presented with a story, our instinct is to want a clear answer, like either I'm going to believe this or I'm not going to believe it. I'm going to believe that it's false. It's a hard thing psychologically to exist in some kind of zone of uncertainty and say, yeah, look, this may be true, this may not be true, or this makes me a little bit more likely to believe that something is true. This now reduces my confidence in believing that that thing is true. But you might think, look, the rational thing to do in general is in fact to occupy that zone of uncertainty and doubt. But Kahneman's point is we have this this propensity to go for the the clearer story, the one that has a lesson, that has an easily digestible takeaway point. I mean, again, if you go back to the presentation by Jacob on COVID stories from different Indian states, one has a tendency to want to know, okay, look, UP did well, Maharashtra did badly, whatever, or vice versa. Whereas perhaps a much more rational space to be is, look, I'm not sure. Some evidence suggests in favor of this, some evidence suggests against it. There's this stuff that I would like to know more about before making a decision about this. I think I wouldn't even say we live in a world. I think part of Kahneman's point is our minds, perhaps for very good reason, go naturally towards the simpler story that one can either accept or reject, and this is one form of human irrationality. And in a way, you can build this back to our initial discussions of people like propaganda, of the power of people like, let's say, Hitler to convince a large mass of people, and maybe the relative importance of certain forms of critical thinking, because you may not have some sexy takeaway line for people to believe, but all you're saying is, yeah, well, I'm not so sure, or I don't know, I'd like to think about it further. That these are not things that perhaps come naturally to us. Does that make sense?
So I would like to mention that many things don't come naturally to us. Like very few things do come naturally. We practice most of the things we do.
Yeah, like what?
Like anything, whatever you would think of that it comes naturally. We still have to practice.
Like brushing our teeth. I mean, as an activity that doesn't come naturally to us, but like we have practiced brushing our teeth since like toddlers or something like that.
Like even like language or something which you would expect that it is very natural, it feels very natural stuff, but it isn't, right? You learn it and you just use it so much that it starts to become natural.
But what's the, why you, what is important about that observation for you?
In my, Kahneman is, it is more about that you can practice this and you can get better at it. That feeling I think is missing here, which I like to mention here.
I see. Well, I didn't read Kahneman as I think he is overall a little pessimistic, but he doesn't think that, he wouldn't write the book, right? He does think that this information is stuff that once people think about, they're going to become better at.
Like this is what like he says, can your system one distinguish degrees of belief? The principle of WISIT that suggests that it cannot. Like I would have phrased that it does not that it cannot.
Oh, I think
Kahneman is
Can you guys hear me?
yes, sir.
So did I suddenly get dropped off from the call, or did it happen to everyone?
So I got dropped off too.
Acha. So again, this must be IIT not able to handle so many people on the call, but I'm not sure why that is so. So what was I saying? I was saying, yeah. So one takeaway lesson is this issue of essentially the lesson might be think about the reliability of sources.
So you were talking about the cannot versus does not thing.
That is the point that you made, that
Yes, sir.
maybe Kahneman is being too pessimistic about our abilities to change our instincts. I guess I ended up agreeing with you, though. Even if one couldn't change one's system one instincts, it might be that we can train our system two to jump in and make sure that the effects of the system one don't they don't carry over into bad decisions that we make. So he has that discussion in that chapter 4 about, or chapter 7 rather, cognitive illusions. It might be that you look at that Muller-Lyer illusion, you still see the two lines as of different lengths, but because you now have this piece of machinery that tells you, look, I'm not going to take seriously what my eyes tell me because I know it's being generated by an illusion. So Kahneman seems to want to do the kind of the positive critical thinking work at the level of system 2, whereas Aditya is pointing out that, hey, maybe some of that can be done with enough practice and expertise at the level of system 1 itself. Is that a fair summary of what you have in mind?
Sort of, yes.
Not completely though.
I think I agree with it, but I haven't thought about it properly, so that's why I just sort of like.
By the way, a good critical thinking response, rather than saying yes or no, I have to think about something more. It's a good lesson, right? Always, it may seem like a bit of a weasel, but let me think about it more. Let me see, what am I missing here? What more do I need to know to make to arrive at that conclusion? These are all incredibly interesting, useful questions to ask. So full marks for critical thinking there. Yeah.
So
Yeah.
so I cannot see your screen.
You can't see my screen for a very good reason, because when my
I don't
call
think-
was dropped,
yeah.
the sharing was also dropped. Can you see it now?
Yes.
Yeah. Okay. So the only other point he makes, which is like in a way a similar point, is we it's the same kind of lesson drawn from another context. This idea that we're very good at telling stories on the basis of facts that don't actually call for explanation. So the kidney cancer case is one example where the fact is generated by a statistical artifact. But the other kind of example he has in mind is where the facts are just what's, this is just chance, it's just randomness. But we have a tendency to see pattern and meaning where in fact there isn't a meaningful pattern or meaning to be derived. He has this example of well, the example he has is this thing called the hot hand. Have you guys come across this phrase? I hadn't come across the phrase before reading this book.
So I have come across this phrase.
The basic idea is, look, if somebody's doing pretty well, it's like somebody's, whatever, in form in cricket or something. Now they're, exceptionally good at, or, they're on some kind of winning streak. Then this person has a temporarily increased propensity to score. And his claim is that, in fact, if you look at the analysis of a large set of games, the sequence of successes and missed shots satisfies all tests of randomness. So again, here one's taking it on trust. Again, it seems like we're so familiar with the idea of somebody's being on form, and that explains why they're doing so well. But the claim being made here is that that kind of thought is an illusion. And he has a nice example. Where is it gone? He has a nice example from his own life, right? He says, where is it gone? So the wartime example. When do you read this? I soon had. Well, actually, we can start even before that. The widespread misunderstanding.
Okay.
So,
The widespread.
Yeah, sorry. For that, Aditya, go ahead.
so I wanted to say something about the hot hand thing.
Yeah.
Actually, a few more studies were happened, and they concluded that the hot hand does exist.
Okay, that's why I wasn't sure whether the studies are actually
So,
inclusive.
So essentially, it's a funny. It becomes funny now, right? That the hot hand fallacy was very famous for a while, as an example of this thing. But now it's it actually does exist, and
Is that right? Can you post some of this stuff on Piazza so we can see the?
or it's I'll search for it.
By the way, this is again, Aditya, you're getting full marks for critical thinking here. One should not be moved by the authority of a book by a Nobel Prize winner or the research he cites, because, in fact, that research can, be questioned by leader scholars, and it should. I was thinking, the book is 20 years old. It was written, well, it got a Nobel Prize in 2002. How old is the book itself? 2011, 10 years old.
It's not 20 years old.
Sorry?
I think book is not 20 years old.
No, it's 10 years old, 2011.
Yeah, 2011.
So it's quite possible that some of these studies have been.
I think you were telling something that full marks for critical thinking. What? No, what did
Aditya, oh no, you know that
I just missed it.
we were responding. I was saying that, well, Kahneman is saying that there's this phenomenon, that this idea that some people are in form and have a hot hand, that Kahneman says that's just an illusion. Actually, it's something that we beholders read into what's essentially a random process. And Aditya said, oh, that's not actually true anymore, or people don't believe uh, this study that these people have done, Gilovich and Robert Vallone, that work, that research on the basis of which people have uh, concluded that this phenomenon is an illusion, that research has now come to be seen to be mistaken, or at least that it's
the tests they used weren't powerful enough to actually find streaks if the streaks actually existed. The statistical tests weren't powerful enough.
tests. It's, you know, the study itself must have been quite old at the time that Kahneman used. By the way, it's quite interesting if you think about something like Kahneman. It just struck me that in response in a way to what Aditya has been saying, Kahneman itself is like not very, like he's pretty certain about his views, right? It's not like, you know, there's good reason to think this, or, you know, we need more evidence to say this. It's like, okay, this one study, and we don't know whose misperceptions are in play. You know, how many basketball games did they study? All of that stuff is stuff that is not open to the reader to examine, and maybe that's a problem for Kahneman's practice. Maybe doesn't fully follow his theory.
I also think that it was an artifact of the right way you have to write books. Like, for one, like they force you to write a particular way, right? In some ways. Especially if you want to write a famous book, right? You cannot write it any which way.
Well, I don't know about that, but I think the point is maybe more, if you want to write a popular book, then you need to have some, like, you know, lessons, takeaway points. Whereas in fact,
the world isn't so clear.
You know, the world is a more complicated place, and one kind of, I mean, Kahneman's, like, the things he's saying is, look, the world is a really complicated place. Don't jump to conclusions. But it is actually remarkable that at more than one place, he'll give one kind of example and say, this example shows some very broad kind of trend or some fact about the way our minds work. Whereas perhaps we need to know a lot more about the studies on the basis of which this is done. If you recall from that chapter, that section on selection bias in the other book, they point out that a lot of psychological research ends up being done on essentially populations of American undergraduates, and then the claim is made that this is a fact about undergraduates, well, about human beings. This fact that's studied in this population tends to be extrapolated to human beings in general. Many years ago, I did some psychological, philosophical work that was on this question. That's another point. Okay, yeah. So I wanted to just to this earlier passage again about randomness. And Sumera, do you want to just read from here?
Sure, sir. The widespread misunderstanding of randomness sometimes has significant consequences. In our article on representativeness, Amos and I cited the statistician William Feller, who illustrated the ease with which People see patterns where none exist. During the intensive rocket bombing of London in World War II, it was generally believed that the bombing could not be random because a map of the hits revealed conspicuous gaps. Some suspected that German spies were located in the unharmed areas. A careful statistical analysis revealed that the distribution of hits was typical of a random process and typical as well in evoking a strong impression that it was not random. To the untrained eye, Feller remarks, randomness appears as a regularity or tendency to cluster. I soon had an occasion to apply what I had learned.
I guess this is from. This is again the caliber transformation has failed us.
Okay, and learned from Feller. The Yom Kippur War broke out in 1973, and my only significant contribution to the war effort was to advise high officers in the Israeli Air Force to stop an investigation. The air war initially went quite badly for Israel because of the unexpectedly good performance of Egyptian ground-to-air missiles. Losses were high. Uh, Losses were high and they appeared to be unevenly distributed. I was told of two squadrons flying from the same base, one of which had lost four planes while the other had lost none. An inquiry was initiated in the hope of learning what it was that the unfortunate squadron was doing wrong. There was no prior reason to believe that one of the squadrons were more effective than the other, and no operational differences were found. But of course, the lives of the pilots differed in many random ways, including, as I recall, how often they went home between the missions and something about the conduct of debriefings. My advice was that the command should accept that the different outcomes were due to blind luck and the interviewing of the pilot should stop. I reasoned that the luck was the most likely answer, that a random search for a non obvious cause was hopeless, and that in the meantime, the pilots in the squadron that had sustained losses did not need the extra burden of being made to feel that they and their dead friends were at fault.
Okay, what's that? What do you guys make of that example? Do you think it's the right decision to have made, or?
In my perspective, it was kind of okay to pilots in case something was actually wrong. Uh, but it is also equally likely that nothing was wrong and it was just luck. But like he said, that it was just a possibility, and like, you don't ignore the existence of other possibilities.
Again, I guess part of the answer to whether it's a good decision just depends upon, how many of these, well, what's the size of the sample, how many flights have people gone on, how bad is 4 versus 1, and it might be, I don't know the answer to that.
And the other thing is what is at stake at experimentation. Like in the last line, he said that sustained loss, the squadron that had sustained losses did not need the extra burden of being made to feel that they and their dead friends were at fault. I mean, in a war, the morale of the soldiers is a huge thing, and
Right.
if it is in some way compromised, then at the like if it is compromised for experimentation, then uh, it I feel it can be okay for people to ignore certain possibilities.
Quite
Depending
possibly
on
that's the case. Of course, if you look at the study, it may not be an issue of fault, right? Maybe that's whatever planes in one squadron are not, they have some mechanical flaw that's perfectly understandable. But anyway, I guess we're running out of time, so let's end with the last the take home. And Sumila, you can read these 2 bullet points and we can stop.
yeah, okay. The exaggerated faith in small samples is only one example of a more general illusion. we pay more attention to the content of the messages than to information about their reliability, and as a result end up with a view of the world around us that is simpler and more coherent than the data justify. Jumping to conclusions is a safer sport in the world of our imagination than it is in reality. Statistics produce many observations that appear to beg for uh,
Causal.
causal explanations, but do not lend themselves to such explanations. Many facts of the world are due to chance, including accidents of sampling. Causal explanations of chance events are inevitably wrong.
Okay, so any concluding thoughts before we close? Do you think this will make a difference to how you look at the world? And if so, how? No? Anything was surprising to you, interesting?
One thing probably not even related to the worldview. It's more of uh, a science thing, like in chemistry. In high school exams, we were asked to come up with explanations for certain phenomena, and like we had to write answers. And I mean that was uh, we were graded on based on how nicely framed the answer is, irrespective of how true or false that can be. So I guess that can be an example of coming up with causal explanations of things that are not otherwise like you don't have a means to verify whether the explanation is actually true.
If you're not actually, if you don't actually care about whether it's true, I would not say it's about coming up with explanations. It's just coming up with answers to the question, right? Like if you don't even, if you're not even checking whether it's true, like if you're not even trying to get a true answer, then it's not about getting true answer. It's just about writing the correct answer to the question as the teacher wants.
I mean, uh, I framed it a bit wrong. It's just that you in chemistry everything is based on observations. Like you observe something and you have to come up with a story. Like maybe this is the reason why this actually happens.
I actually like this is true. I think for our level, but not true generally. Like
yeah, of course, not generally. I'm talking about high school level chemistry.
So interesting that our training in these matters goes against. I mean, you'd hope that education in general would be an education in in the right kinds of practices, but it seems like a lot of our education, and maybe across the world, is education in actually the wrong kinds of practices that then requires to be undone later on.
And there have been times where we are asked to I can't really recall a particular example, but we are asked to figure out a pattern. Like we are given a data and we are asked to figure out what kind of pattern it follows. It might be possible that it follows none, but we just have to come up with something.
Right, and maybe the lesson there is okay. In faced with this kind of situation, consider the possibility that it's just chance. I wish I knew. I really regret not having taken probability and stats as an undergrad. I always feel like I have a missing gap in my understanding of these issues.
I mean, you could just learn right now.
I am planning to. I've seen this summer, like for many years. I've been, that William Feller that he talks about. I've had that book on volume 1 of his book on probability for many years. Look, I just need some time to just sit down and work through it. So I feel like now inspired to do that, or maybe look up join a MOOC that teaches this stuff.
So also like Sumita said about like if we have data and we need to find a rule for the data,
Yeah.
I would like to say that in usually those sort of questions, the data is really tightly packed. Like normally the data you get has a lot of noise, and that's why it's a problem when drawing conclusions. Like the data I have usually gotten in these sort of questions was like almost in a straight line. Maybe there's a problem with
Yeah,
the
I mean,
may-
for
maybe the error is in the second significant digit, but it's almost a straight line and stuff. So I don't think that's a
I mean,
problem.
for questioning purposes, it's not really important because the question is framed in a way that people can answer. But in general sense, that what answering that kind of questions teaches us regarding research practices. Like,
I'm not even sure, right? Like if your data is coming out to be almost a straight line, that is very rare. It does not like by it would not happen by chance easily, right? That almost always
yeah,
shows a
yeah,
underlying mechanism. If it is like almost exactly a straight line.
yeah. I mean, straight line is a bit easier to observe, but like it forms a curve, maybe some conic or something like that. It's more harder to observe, and the randomness may be like affect it more.
So I think we should. I mean, it sounds like they're two different issues. This is also an artifact of an exam, or it's an idealized kind of condition. So maybe we assume there that what is being tested is some understanding of a particular theory, and then therefore these numbers don't even have to be correct. They just have to be such as to require you to exercise that particular skill. But maybe one thing that can do is in a way distort one's sense of how certain one should be about these results. I think that's the point that at least my interpretation of what Aditya said. Anyway, guys, so we're out of time. So let's call this to a close, and we'll wrap up on Thursday and Friday. Please, somebody just send me an email. We'll do an in-person tutorial for the last tutorial of class. Yeah.
Sure, sir.
Right.
It's the last tutorial.
Sorry.
It's the last tutorial.
Well, it's the last week of class.
Aditya, we have majors from 3rd April.
1st April is the last day of class.
Not third, I think 5th April. No.
But some people would have since 3rd, right?
Well, April 1st is the last teaching day.
Of course.
Yeah, today is Monday, right?
Yeah. So we won't have a Wednesday tutorial. We'll just have a combined Wednesday Friday tutorial on Friday.
Friday, okay. On Friday on 1st April.
Yeah, is that okay?
4 to 5, right?
Yeah. I mean, if there are people who can't make it to that, then we'll stick with the Wednesday tutorial as planned. Would you prefer that?
So an in-person tutorial would be more fun.
Yeah, in-person tutorial.
No, so here's what I'm saying. I'm saying in any case, we'll do in-person on Friday 4 to 5. I'm asking, in addition, would you like a tutorial on Wednesday 5 to 6? Or can everyone just come for that one tutorial?
Yes, sir. I think people can. I mean, I can.
Okay, well, let me know. You can always email me, and I'm happy to hold a tutorial on Wednesday immediately. Okay, guys. See you then.
Thank you, sir.